Hi everyone, in this video we're going to look at 17D, confidence intervals for the population proportion. There's a bit of information in 17D, but basically I'm going to try to explain it as best as I can because you kind of already covered similar content. Okay, so first of all, point estimate. So basically, if you don't know what the population proportion is, you can use the sample proportion. So the value of the sample proportion p hat can be used to estimate the population proportion p. Since this is a single valued estimate, it is called the point estimate. So the example that the textbook gives you, you might want to know the proportion of primary school children who regularly use social media. So we don't know the population proportion P, but collecting information about, because collecting about the information about the whole population is not really feasible, so a random sample must suffice. Okay, so if you think about all the primary school children in Australia and surveying them on their social media use, it's just not possible. So we're looking at a random sample. So what information can be obtained from a single sample? So certainly we can get the sample proportion, and that will give us some indication of the population proportion. So obviously the larger your sample size, the closer that sample proportion will be to your population proportion. And we call that the point estimate of P. So just basically population proportion is equal to sample proportion in very large sample sizes. Okay, so I'm going to just continue on to interval estimates because this is pretty much what 17D covers. So an interval estimate just tells us how far away we are from the mean. Okay, and we've kind of covered this before. So what I might do is just sneakily go back to 16B, all right, with the normal distribution. So remember, we know that approximately 68% of values are between 1 standard deviation below and above the mean. 95% is approximately 2 standard deviations below and above the mean, and then 99.7%, 3 standard deviations above and below the mean. Okay, so remember we covered that in 16B. So with 17D, I'll just quickly go back. We're basically using confidence intervals. So the formula we use, and this is on your formula sheet. Let me just scroll. Actually, I'll go to your notes because it's in your notes. Not that first one, I'll explain that in a second, but this general one here. So it is on your formula sheet, and basically, where's my pen? You're just doing your mean, which is the same as your sample proportion, minus the number of standard deviations, and then your mean plus the number of standard deviations. Now, K just represents how many standard deviations you have, because remember this formula here is a formula for the standard deviation. So if I scroll back up to this one here, if we're looking at 95%, so remember in 16B we said it was 2 standard deviations above and below. Well, there's your 2 standard deviations. Now obviously it's rounded to 2 decimal places, but we know it's always going to be an approximate. So that's your mean minus 1.96 times standard deviation, and your mean plus 1.96 times standard deviation. This 1.96, if you're interested where it's come from, let me just go onto the calculator. So you can always find them out if you forget these numbers, but on your exam 2, you'll be given these numbers. Okay, so not that one, sorry, I should focus and not try to talk at the same time. So we want to go to inverse and inverse normal. All right, so if I just go to center, it's probably a bit better because we're looking at the proportion in the middle. Okay. No, so for this one, we're looking at 95%, so it's 0.95, so 95% confidence interval. Your mean and your standard deviation, we can just leave them as 1, so just a standard normal distribution. And you can see you get negative 1.9599, which is 1.96. Okay, so that's because the normal distribution is symmetrical, it's going to be plus or minus 1.95. Now, if I was to do 90%, okay, so you might come across questions with 90%. We do the same thing. We're going to go to center. Probability is 0.90 and still standard. So your value of, if I just scroll down, K in this confidence interval would be negative, well, it's already negative, but 1.64. If I wanted to do 0.99, it's going to let me do that. Come on, let me type in 9. There we go. K is going to be 2.58, depending on how many decimal places you want to do. We already know that p hat is our sample proportion and n is our number of trials, or our sample size. Sorry, I should stay away from our binomial distribution. So n is your sample size. So you can substitute your values into that. So basically that just means, oops, that's a terrible, don't want to draw a line anyway. Let me draw my normal distribution. Okay, so we've got p hat in the middle, all right, because it's going to follow normal distribution. And then we're going to be, this one here is negative 0.96 times standard deviation and 1.96 times the standard deviation. That doesn't look like a standard deviation. So that's 95%. Okay, so it's just looking at this distance here and this distance here. So the confidence interval. All right, I'm going to go back to the textbook and we'll watch a video. Let's go back to example 12.
This question here is asking for the approximate 95% confidence interval for the proportion of primary school children in Australia who regularly use social media. We've got a sample size of 20 students, and the proportion of these students who do use social media is 0.7. So we've got p hat as being 0.7. We've got our sample size of 20. To find the lower bound of our 95% confidence interval, we're going to use this formula here. And to find the upper bound of our 95% confidence interval, we're going to use the same formula, but replace that minus in there with a plus. When we work that through, we end up with a lower bound of 0.499. To do the same with the upper bound, we end up with an answer of 0.901. This gives us an approximate 95% confidence interval of 0.499 to 0.901.
All right, so let me just go back to, where am I going? Let's go back to the textbook. Okay, so you can see there's a lot of information on there, but you just really need to remember 95% confidence interval, that 1.96. There was a question on a past exam where you had to use this formula, but because it's on the formula sheet as this second general one, you may be asked for 90%, 99%, not necessarily 95%. So you can remember the 1.96, and we'll see that more than the other values, but you do also need to know how to find them on your calculator. So just inverse normal. Okay, I'll go through it again. Inverse, and just choose center, and Again, if we wanted 90%, it's 0.9. Just do the standard. Okay, so your value of K would be 1.64. All right, so there's example 12. Let's just move along. So in example 13, we're going to be using the calculator again. So a survey found that 237 out of 500 undergraduate university students questioned intended to take a postgraduate course in the future. Find a 95% confidence interval for the proportion of undergraduates intending to take a postgraduate course. All right, so you could calculate p hat from this, so 237 over 500. You could also calculate the standard deviation because you've got n is 500 and you've got p, which is 237 over 500. But you could also do it on your calculator. So let's follow the instructions here. So we go to menu, statistics, and I've got values in there, but I don't think it matters. We've got calculate, interval, and just down the bottom. So we want 1 Z. Okay, go to next. And I'm going to type in the same values just to make sure we get the same answer. So we got 95%. X is 237. How many who are planning on doing postgraduate? And 500 students. All right, so if I just scroll down. Okay, so we've got a 95% interval between is between 0.4302 and your upper limit is 5178. Okay, if you were rounding that. P hat is 0.474 and N is 500. So you could do it that way also to get your lower and your upper limit. So instead of having to calculate P hat, it's calculated it for you. So that's just, what was it, 237 over 500. All right, in question 16, calculate and compare 90%, 95% and 99% confidence intervals. So we've got now 90 and 99%, whereas before we only looked at 95%. For the proportion of primary school children in Australia who regularly use social media, if we selected a random sample of 200 and find the sample proportion to be 0.7. So you can see they've substituted the values in. So for 90%, remember I got that 1.64 when I did that before on the calculator. And for 99%, I did the 2.58. So on your calculator, where are we? Okay, so you can type this in. If I just go back. Now, you can see here, it's not asking for p hat, it's asking for x. So if you wanted to use something like this, you can calculate p hat, not p hat, x by just doing 0.7 times 200. Okay, so 140 people regularly use social media. So if you wanted to go back and use that function that we did before in statistics, calc, interval, what do we want? One. Okay, so confidence interval, so let's do the 90%, so 0.9. X was 140. And N is 200. So if I just go to next, all right, so it's calculated it for you here as well. Okay, so you can do it either by substituting it in, or you can see here it is pretty straightforward to do this because you might even make a mistake here. But let's say this was a exam 2 extended response question. You should actually be writing this working out. So this formula is on your formula sheet, but obviously you can get these values on your calculator. All right, you can do the same thing if I go back and change my confidence interval to 0.99. All right, so we get those values you can see. And you can do 95% as well. I think we did, oh no, I didn't do that example with you, but it was done. And there it is there, 0.636 to 0.764. So basically, here's your mean, and you can see, well, not one standard deviation, because one standard deviation is 68%. This is your confidence interval. Okay, so this bit here and this bit here. So you can see, where are we? 90%. We're going from 0.647 to 0.753. So you can clearly see that on the scale. But the distance from the mean, 0.7, is this part here. All right, so 1.64 times your standard deviation. So we're subtracting that from your mean, and then we're adding it to your mean. Okay, so that is basically what it means. So 90% confidence interval there, and then you've got 95% and 99%. So it gets wider the larger the confidence interval. So from this diagram, it can be clearly seen that the effect of being more confident that the confidence interval captures the true value of the population proportion means that a wider interval is required. All right, just another thing before we do some questions is the margin of error. So your margin of error is just the value of your, what are we doing? The standard deviation times whatever that confidence, well, not your confidence interval, but that value of K. So for 95%, we've got 1.96. So if I go back to here, because I can draw on this, okay, what I circled is your confidence interval. So this here is your confidence interval. So if you wanted to, sorry, not your confidence interval, your margin of error. So I'll write that on here, and that's your margin of error. So let's say, you know, we were filling up bottles of soft drink, and obviously you couldn't have, you know, 1.25 litres every time, but you wanted 95% of the time for them to be a certain volume, and that would be your margin of error. So what you can have either side of that 1.25 litres. All right, so I'm just going to go back to here and we'll watch example 15 and then we'll do some questions together.
To find the sample size required to achieve a margin of error of 2% for a particular 95% confidence interval, we're going to use our margin of error formula, and that is that 0.96 multiplied by the square root of p hat times 1 minus p hat over n needs to be equal to 0.02. This formula here gives us our margin of error. So when I replace my p hat with 0.7 and work that through, I can start rearranging this formula to find the value of n. But n is a sample size, so we can't have that as a decimal. Therefore, the sample size we need would be 2017 to achieve a margin of error of 2%.
Okay, so you can see she's just used that formula, although I think she said 0.96. So it's 1.96. That's for 95%. Remember, for 90% and 99%, they do change. And you can find any percentage just by using your inverse normal. So basically, just this formula will tell you your margin of error. And if you're given your margin of error, so in this case it's 0.02 or 2%, you could find p hat or you could find your sample size. So this question has given us p hat, our sample proportion. But if they if you had to find your sample proportion, then you can just substitute in for everything else. Okay, so just using the same formula in a different way. Okay, let's have a look at a few questions. All right, so question 2. A newspaper wants to estimate the proportion of its subscribers who believe that the government should be allowed to tap telephones without a court order. It selects a random sample of 250 and finds that 48 of them believe that the government should have this power. Find a point estimate for P, the proportion of subscribers who believe the government should be allowed to tap their telephones, and then 95% confidence. So remember, P is equal to P hat. So for this one, we've just got 48 over 250. So we can just quickly do that on the calculator. So 0.192. Okay, so remember you should be showing your working out. So for question B, obviously we can do that straight onto the calculator, but we do need to get into the habit of showing working, especially on the exam if it's worth more than 1 mark. So if we're doing the confidence interval, it's just your mean minus, so 95% is 1.96 times the standard deviation. So it looks like a complicated formula, but you're familiar with everything in it. Oops, I should be doing P hat, P hat. So there's our lower, and then our upper is the same thing, but plus. All right, so on the calculator, let's just go and do that. So I like the statistics one. Let's just go here, statistics. So calc, interval. All right, next. All right, your confidence interval is 95%, so 0.95. X is, what was it, 48. And N is 250. So this will also calculate P for you, or P hat. So remember, when you don't have the population proportion, you can just say it's the same as your sample proportion. Okay, so there you've got your lower, your upper, there's P hat for you. So what have we got? 1432. What? I feel like there was a 7 in there somewhere. What did I do? Oh, okay. And 2408. Okay, so there's your confidence interval. All right, 0.1432, not a Z, 0.2408. All right, question 6. A manufacturer claims that 90% of their batteries will last 50 hours. A random sample of 250 batteries, 212 lasted more than 50 hours. Use this information to find a 95% confidence interval for the proportion of batteries lasting more than 50 hours. Okay, so let's write down what we have. So 90%. All right, so we can also say that is P hat. Random sample of 250. Actually, so 90%, that's not P hat. P is 0.9, but P hat for this sample proportion, it's 212 over 250. Use this information to find 95%. Okay, so we just got to write down our formula. So we've got P hat minus, so 95%, 1.96 times your standard deviation. And then plus And there's your standard deviation. All right, so I'm just going to put that straight into the calculator. All right, so X is 212, and we've got 250 again, which is good. All right, so P hat is 0.848. And you can see it's very close to your population, so it's 90%, so it's very close to 90%. Okay, so we've got 0.8035. And then our upper is 89.25. All right, an inspector requested further information. A random sample of 2,500 batteries was selected, and this time, oh, now word's going to die on me. This time, 2,120 lasted more than 50 hours. Use this information to find the 95% confidence interval. All right, so I'm going to just quickly do that on my calculator because it's just a change of numbers. So this time we're looking at 2,120 batteries that last more than 50 hours, and N is 2,500. All right, and then comparing them, so you can see that it does get narrower. So we have the same value of P hat, but our value of N has increased from 250 to 2,500. So the confidence interval is just a little bit narrower. All right, so it's initially for 250, it was 0.8035 to 0.8925. And now it's those two values have become closer together. All right, how many questions have I got? Let's do two more. All right, we'll keep going until a word dies on me. Bob is thinking of expanding his pizza delivery business to include a range of desserts. He would like to know the proportion of his clients who would order dessert from him, and so he intends to ask a number of his clients what they think. Now, just before I move on, when I see the word dessert, I always think of people who misspell it and write desert. So like, oh, I'm really looking forward to desert tonight. And it's like, okay, the way you need to remember it is what would you like more of? A desert or dessert? So if you want dessert more, we have more S's. So it's two S's. So that's the way I always remember. So a little spelling lesson for you there, girls. Now I can't erase it. Okay, so you want more dessert, so it's double S's. Double S. Anyway, let's move on. Question A. Bob thinks that the proportion of his clients who would order dessert is around 0.3. Determine the size of the sample required for Bob to achieve a margin of error of 2% in an approximate 95% confidence interval for this proportion. So let me just all right, so your margin of error is equal to, so 95%, so 1.96 times your standard deviation, which is P hat 1 minus P hat over N. All right, so M is equal to 0.02, and what are we solving for? N, so 1.96, 0.3, 1 minus 0.3 over N. And then you can just do solve on your calculator. Now, obviously, if it was a show that question on your exam, you would probably have to show a little bit more working out than this. So you would need to go and do the algebra involved. Obviously, you couldn't, actually you could do it by hand if we had nice values to work with, or we just leave them as surds, but let's just leave it as is. So 2016-84. All right, so we are looking at sample size, so we do need to round that, so 2017. So very similar to the example question. All right, let's do B over here. Bob's business partner, Phil, thinks that the proportion of clients who would order dessert is around 0.5. Determine the sample size required. Okay, so we do exactly the same thing. The only difference is P is now 0.5, so we can do that. What is the effect on the margin of error if Bob is correct, but they use a sample size from Phil's estimate? Oh, let's just get the answer first. And then Phil is correct, but they use a sample size from Bob's estimate. All right, so for question B, for Phil, he got a sample size of 2,401. Okay, so he's got a larger sample size. So in question C, they're switching sample size. So this time, what is the effect on the margin of error? And I'm just going to be sneaky and just put the solution up because I don't want Word to die on me without doing all the questions. Okay, so what we're doing first is if Bill was correct, so he said the sample proportion was 0.3, but we switched the value of M this time to be 2,401. So we recalculate M. So before M was 2%, and this time it comes out as 1.8. So for Bill, the margin of error would be less than 2%. Now for Phil, if we used the sample proportion of 0.5, we would get a margin of error that is more than 2%, so 2.2%. So question D is asking, what sample size would you recommend Bob and Phil use? So okay, so it's saying, would you like to have a sample size greater than 2%? M is your margin of error, so you'd probably want less margin of error, sorry. So 2% or less. So you can see when Bill used a larger sample size, he got 1.8, but when he used his original sample size, he got 2. So it's probably better to use a sample size of 2,401. If you use a smaller sample size, your margin of error will be bigger. All right, let's move on. Hopefully, the computer doesn't die on me. In a survey of attitudes to climate change, a total of 537 people and a sample of 1,000 people answered no to the question, do you think the government is doing enough to address global warming? Calculate and compare the 90%, 95% and 99% confidence intervals for the proportion of people in Australia who would answer no to that question. All right, so let's just do all this on the calculator. So we'll do the 90% first, 95% and 99%. Now remember, on your exam, you should be substituting the values into the formula for the confidence interval. So to get those confidence intervals, remember we go to inverse, norm, and to get, so we'll just go to center. Come on. You're going to work for me. Let's try again. Okay. All right, so for 90%, 0.9. Okay, so there's your value there. Okay, so if you don't have to memorize these values, you can just get them from your calculator. But for these confidence intervals, I'm just going to be using the statistics calc interval. Come on. And we want one prop. All right, so the confidence interval for the first one is 0.9. X is 537. And N is 1,000. So you'll be given P hat here, so you could substitute that straight into your formula for the confidence interval. Okay, but you can see your answer there as well. So 0.511 and 0.562. You can write them down. Let's quickly do 95. So the same thing, we're just changing the C level, the confidence. All right, so we can see those values there, so you can copy them down, and let's go back and do 99. All right, so there's your values there. What I might do is just sneakily go onto the textbook. Oh, they didn't do the substitution either. All right, so you can see your interval width increases as confidence levels increase. And remember, we looked at that in the section. Not that one. Where are we? Did we look at it? I thought we did. Maybe we didn't. This one. There we go. All right, so as your confidence level increases, obviously the length of the interval increases. All right, I'm going to leave it there. So basically looking at confidence intervals, remember this formula down the bottom is on your formula sheet, but it might be a good idea to put 95%, 90 and 99% already in your bound reference, just to have it there in case you need it, but you can use your calculator to find it anyway. All right, bye.